In the previous two lectures, we have discussed about the degree of static as well as kinematic indeterminacies of structures. And now, on the basis of that number, that is the number dk or ds, several methods are devised to analyze structures. Now, in this section, we are going to discuss about what are the methods of analysis available for statically determinate as well as indeterminate structures, and what are the applicability of such methods. So, generally, the analysis methods are divided into two categories. One is called as the force method of analysis or force methods of analysis. Second category is the displacement methods of analysis. Essentially, we know that if the primary unknowns in a structure are redundant forces, the method of analysis can be called as force method. Very simple. If forces are the unknowns in a method, we call the method as force method of analysis. If independent joint displacements, that includes translations as well as rotations of joints, we can call them collectively as degrees of freedom, as we saw earlier in the previous lecture. If they are the unknowns, the method can be called as a displacement method of analysis. There are many choices of redundant forces when you go for a force method of analysis, as we have discussed in the case of static indeterminacy of structures. But whenever we go for a displacement method of analysis, there is a unique choice of displacements. To illustrate that further, let us take a simple frame. Let that be unsymmetric frame like that. The ds, degree of static indeterminacy for the structure, would be equal to 3. dk will be equal to 3. So it is a frame in which ds and dk are having the same number. Now ds, it refers to the number of unknown forces in excess of the number of equations. If you try to identify them, you see that these are the number of forces to be removed from the structure so that the structure will become a statically determinate one. We can see that if we remove this support from here, this structure subjected to certain external loads, of course. There are loads from here, there are loads from here, distributed also. If we remove this support wholly or fully, this structure will become statically determinate. That is, we can consider the reaction here, say vertical reaction, horizontal reaction, as well as this moment as a reaction. If you remove these three forces, let us call them by name V, H and M, the structure will become statically determinate. There are other choices too. We can consider, say, the moment at this support, the moment at this support, and the moment at this support. If you remove these three moments from these three, say, joints in this frame, instead of these three forces, this structure will again become statically determinate. So likewise, there are few more choices for degree of static indeterminacy and in force methods. Whereas in case of degrees of freedom, in a displacement based method, the dk is equal to 3 here. The rotation at this joint, rotation at this joint, and a possible translation along this direction are the only 3 degrees of freedom for this structure. With proper idealization, the rotation of this joint, rotation of this joint, and a sway, maybe to the right or to the left, are going to be the degrees of freedom for the structure. This joint will not translate or rotate, this joint also will not translate or rotate. So there is a unique choice of degrees of freedom in a structure, whereas there are many choices for unknown forces in a structure, joint forces. That is what is given here. Now, as it is obvious, when the degree of static indeterminacy is less than the degree of kinematic indeterminacy, it is always good to go for a force method of analysis. The best example is skeletal pin jointed frames. For example, if you go for a structure like this, a truss, plain truss like that, so let us have a third support over here, which makes it statically indeterminate. Right. We can identify here that the value of ds equal to 1 and the value of dk will be equal to 2 translations here, 2 here, so that becomes 4 plus 2, 6 plus 1, 7 plus 1, 8. dk is equal to 8. So if you solve this truss by a force method, you need to solve for only one additional number of unknown in excess of the number of equations, number of equilibrium equations. Whereas if you go for displacement based methods, you have to solve for 8 number of unknowns. So whenever the number of degrees of freedom is greater than the degree of static indeterminacy, it is preferable to go for a force method. Well, in case of rigid jointed frames, or continuous beams, the best choice of redundant forces would be joint moments. As I have discussed over here, this is an example of a rigid jointed plane frame. So instead of going for this H, V and M, we can go for, say, the bending moment here, or the moment at this joint and moment at this joint as the best choice for the unknown forces. Now, based on the considerations of degree of freedom or degree of static indeterminacy, a few of the force methods of analysis as well as displacement based methods are listed in this slide. We will just go through that very quickly. One of the force methods is known as the method of consistent deformation. We will discuss that in detail in the coming lectures. Another method is known by the name unit load method. It is based on strain energy and Castigliano's theorems developed in 1879. Another one is Clapeyron's 3-moment equation method developed in 1857. Column analogy method is there. Matrix flexibility method. These are a few of the force methods available, in which in this series of lectures we are going to discuss about the first one in detail, the second one to some extent, and most importantly the last one. A few of the displacement methods are slope deflection method, in which, as it is clear, slopes as well as deflections of the joints are going to be unknowns in case of rigid jointed frames. Moment distribution method, which is a step-by-step solution procedure for the slope deflection method, and the matrix stiffness methods. There are several of that kind. There are several approaches for stiffness methods, and we will discuss in this series of lectures the slope deflection method in detail, and further the matrix stiffness method on the basis of that. We will discuss about the structure approach of matrix stiffness method, and further we discuss about element approach to develop the stiffness matrices, and further we discuss about the direct stiffness approach to solve structures or to analyze structures using the stiffness approach. So before we go to the method of consistent deformation or slope deflection method, let us see what are the basic equations which are used in a force method of analysis and a displacement method of analysis. We go for a force method of analysis for a statically indeterminate structure because the unknown internal forces could not be determined using the equations of equilibrium alone. So the additional equations which are formed in a displacement in a force based methods are known as the compatibility conditions. Which are essentially the compatibility of displacements. It is available from geometry. In case of a displacement method of analysis, we start with degree of freedom and we solve for the degree of freedom finally in the method using the equations of equilibrium. We can say, in a sense, in a structural analysis problem, compatibility conditions, that is of displacements, and equilibrium equations of forces are the set of equations available. In an indeterminate analysis, we consider the compatibility conditions for force methods and equilibrium equations for displacement methods. And now we have to discuss about the methods one by one. So, in this section, what we have seen so far is what are the methods of analysis in brief, and what are the approaches to the methods of analysis, and briefly what are the names of the equations which are used in these kinds of methods.